Assalamu alaikum. Let's start solving Unit 1 paper for the 8th of Jan 2026. And the first question, and let's say Bismillah. Which of the following units can only be used for a vector physical quantity? What's the meaning of vector physical quantity? Vector physical quantity, it's a type of quantity that can be fully defined by its magnitude and direction. So let's define all of these units, which one can be scalar and which one is the measuring unit of a vector physical quantity. Firstly, you know that joule is the measuring unit of both energy and work, and both of them when you define them we use only their magnitude. The kinetic energy is about 18 joule. The elastic potential energy stored in a spring is 32 joule. We have the gravitational potential energy stored inside an object that's placed on a specific height is 100 joules. So energy and work are scalar physical quantity. Then the kilogram. All of us know that the kilogram is the measuring unit of the mass, which can be fully defined by its magnitude only. My mass is about 100 kilogram. So we don't need to define the direction of the mass because the mass has no direction. So the mass is also a scalar physical quantity. And you should memorize for each part you studied which one is a scalar and which one is a vector. In the first part you study the part of kinematics, speed, time, displacement, distance, acceleration, force, momentum, impulse. All of them you should know which one and memorize which one of them is a scalar and which one will be a vector. I will move to the last one, D, because the correct answer is C. W is a measuring unit of the power, which is the abbreviation for watt. Power is the energy consumed in 1 second, or rate of consumption in energy. So energy and time are a scalar physical quantity, and also the power is a scalar physical quantity which can be fully defined by its magnitude only, while C is the measuring unit of the force, Newton, and it's a vector physical quantity which will be defined by its magnitude and direction, because when you apply a force on an object you should mention what's the type of the force. For example, we have the friction force. Friction force, it's always opposes the direction of motion, so you should mention the part of its direction. This for the first question. Let's move to the second question and say Bismillah. An apple falls freely. What's the meaning of falls freely? It has the same meaning as dropped. Dropped and falls freely means that the initial velocity, which has an abbreviation of u in the kinematic part, and so that equations. So u equal to 0. Okay, from rest until it reaches the ground, the apple falls a distance s in a time of t. Which of the following gives the relation between s and t? We have only one formula, it's two formulas that contain the relation between s and t. First one, it's s, which is equal to v plus u divided by 2 multiplied by t. Second one is s equal ut plus half at square. When the apple falls freely, it means that the acceleration here in this formula, in the second formula, is the acceleration due to gravity. So you should replace it by g, which is the gravitational field strength, or the acceleration due to gravity, which is measured by Newton per kilogram or meter per second square. Okay, so when we substitute by with u equals to 0, so we have s is equal v divided by 2 multiplied by t. And in the second case, we have S is equal to half gt square. In the first one, we have a direct relation between S and T, but as the time passes, we have V will also change. So as the time passes, V increase, T increase, and V increase. So S will be increased by and affected by two factors, which is T and V. While in the second formula, we have S equal half gt squared. So half is a constant value. G is a constant value based on the planet where this situation or this the object falls on is also constant. So G is constant, by the way. So S is directly proportional here for one only factor, which is T squared. So we have S is directly proportional or has a relation between S and T. There is a relation between S and T, which is S is directly proportional to T squared. So the correct answer will be letter D. Let's move to the third question and say Bismillah. We have a white ball moving with velocity v. Okay, let's draw it. We have a ball, white one, that's moving with velocity v. And the velocity is a vector physical quantity. Collide with a stationary red ball. Okay, so we have here the red ball. Okay, here is the red. Sorry. Here is red, and its velocity is 0. There is no velocity for it because he said that the velocity is, the object is stationary, which means that its velocity will be equal to 0 with the same mass. So the mass of the white ball is m, and the red ball is also m. Okay, after the collision, so here is before the collision. After the collision, the white ball is stationary. Okay, let's repeat the same thing. Okay, here, and we have the velocity of the white ball will be 0 because he said the white ball is stationary and the red ball move with velocity v. So we have the red ball will move to the right direction. It's logic, with velocity v. Which row of the table describe what happened to the total kinetic energy and the total momentum of the balls during the collision? And we have a statement that said that the momentum is always conserved, which means that the momentum should be the same. The momentum should be the same. It's always be the same. So A and C will be wrong. Okay. What about the kinetic energy? If the collision is elastic, the the total kinetic energy will be the same. And before collision will be equal to after collision. But if the collision is inelastic, so the total kinetic energy should be decreased as the energy will be transferred to the surrounding like heat, sound, and other forms of energy like the internal energy. Okay, so let's apply the formula of the kinetic energy before, which will be half mv square plus 0. Half mv square for the white ball and 0 for the red ball. After collision, it will be 0 for the white ball and it will be half m, and because they have the same mass and same velocity with velocity v. For the first situation, for the white ball, it moves with velocity v, while the red ball, after the collision, it will move with velocity v. So it's half mv square. So we have half mv square plus 0 equals to half mv square. 0 plus half mv square equal half mv square. So the kinetic energy will be also conserved and the collision will be elastic collision. The type of collision will be elastic collision and the momentum will be conserved and the kinetic energy will be the same. So the correct answer will be letter D. Let's move for the fourth question and say Bismillah. A toy car rolled down a ramp. The ramp was at an angle of theta to the horizontal. Okay, let's find the trigonometric function for the theta. We have cosine theta and we have sine theta. Cosine will be equal to the adjacent over the hypotenuse. Cosine, it's you have like statement so, ko, or kah, to. So we have the cosine equal adjacent over hypotenuse. The adjacent for theta will be x and the hypotenuse will be the long ramp, which we can mention it's the distance. Let's name this line will be the distance covered by the toy car, while sine will be opposite over hypotenuse. Opposite for the theta will be y, and then the hypotenuse will be the distance. Okay, the resultant force of the car was F, and it will be downward. The car moved a horizontal distance x and a vertical distance y as shown. By the way, the car is accelerating downward because the force will be in the direction of motion. Which of the following expression gives the work done by F as the car moved down the ramp? We know that the formula of the work equal force multiplied by the distance moved, and they should be in the same direction. So here we have the force downward and the distance will be the length of the hypotenuse. So it will be force multiplied by the distance. Work equal to F. We have the distance. So it's not A and it's not C. We have B and D. So instead of D, he uses the cosine and sine. From this formula, you can replace between D and cosine theta by replacement. So we have D is equal to X cosine theta. And for this formula, you can replace between D and sine theta. So we have D is equal to Y over sine theta. You can substitute by D in in this formula by the two rules or two formulas of D. So we have the first one, F, work equal F, multiplied by D. So I will replace D, X over cosine theta. Or you can find the work equal F multiplied. I can replace D by this one. So it's Y over sine theta. Which one of them is located in the choices? So we have, it will be letter B, because work is equal to F multiplied by X divided by cosine theta. Let's move for the next question and say Bismillah. A force of 20 Newton. You know that the force is a vector physical quantity, and we have some mathematical operation in the part of vector algebra you can apply for each vector physical quantity. Like if the two forces or the two vectors are in the same direction, you can add them. And if they are in opposite direction, you can subtract them. But firstly, they should be from the same type. And you should add the two forces. You should add the two displacements. You should add the two velocities, and so on. You can't add force with a displacement and velocity with a momentum. Okay. And if they are perpendicular to each other, so you can use Pythagorean theory. Okay. So a force of 20 Newton and a force of 35 Newton act at a point. The forces act at a right angle. Okay, so we have the right angle, which means that you will use a square root for getting the hypotenuse or the resultant to each other as shown. So they are perpendicular to each other. Which of the following expression gives the magnitude? He asked about the magnitude only. So the resultant in case of the perpendicular vectors will be square root for the first one square and second one square. So it will be 20 square plus 35 square. And so the correct answer will be letter D. If he asks, by the way, for the for the direction, we can represent the direction by an angle. So the direction will be tan inverse of the vertical over the horizontal. The vertical represents the opposite and the horizontal represents the adjacent. So it will be 20 over 35, and you can use your calculator to find the direction in degree. Let's move for the next one and say Bismillah. Okay. A driver applied the brakes to stop a car. Stop means that the final velocity will be equals to 0. The car has a constant deceleration. Before we solve this question, let's explain each answer separately. Okay, first one, or the main or measure for all the graphs, we have the gradient. The gradient is the change in the y-axis over the change in the physical quantity on the x-axis. So the change on the physical quantity on y-axis, which is delta velocity, all of them contains velocity. Okay, and then we have the change in time, or the time of change. So delta v over delta t will be equal to the acceleration. So the gradient in each graph of them will be equal to the acceleration. Okay, first one, the gradient will be equals to 0. So the acceleration will be also equal to 0 because there is no change in y-axis. So the object moves with constant velocity, which means that there is no force acting, or the resultant force acting on the object will be equal to 0, and so the acceleration will be equal to 0. Second graph, the gradient is constantly or constant value, because if you find the gradient at each 2 points from the graph, it will be the same value for the whole interval of time. So the gradient is constant, and so the acceleration will be constant. And the gradient is negative because it returns to the 0. So it will be negative and constant value. Okay. Third one, C. We have the, firstly, you can divide the line or the graph into 2 sections. The first one is a straight line. Look at this. It's straight line, and then it becomes a curved line. If you draw a straight line, it can't touch it, so the line will be changed. So we have 2 intervals. First interval, we have the gradient is negative, so the and constant, by the way, so the acceleration will be also negative and constant. Okay, and then the gradient will be negative, but it's decreasing. So the acceleration will be negative and decreasing. Why? Because when you get the when you draw the tangent to the line, here is the first tangent, and here will be the second tangent. So the angle between the line and the horizontal line will decrease, and so the gradient will decrease. Last one, which is letter D, we have firstly constant speed, because the tangent to the curve will be parallel to the time x, so it will be constant speed. And then the gradient is increasing. If we draw, it will increase. So the gradient will be negative because it's decreasing, and then it will, because the angle between the x-axis and the line is increase. By the way, we have the first angle will be equal to 0, second angle, and then the third angle. So the angle is increasing. So the gradient will be negative and then it will be increasing. So the acceleration will be negative and increasing. And he asked about what's the question? I forgot it. We have the constant deceleration. So we have the constant, here is a constant, here is a constant, decreasing, so it's not constant, increasing, so it's not also constant. So it's not C or D. But he asked about deceleration. So we need an acceleration. It will be letter B. Okay. So we have the car stop. So the graph should reach the zero velocity. And then the car has a constant deceleration. Constant, the line should be straight line. And then deceleration, which means that the gradient will be negative. And let's move to the next question and say Bismillah. The question said, a person doing a parachute jump falls at a terminal velocity. What's the meaning of the word terminal velocity? Terminal velocity means constant velocity. And constant velocity when the total force acting on the whole system will be equal to 0. When the downward force equal to the upward force. Okay. And the terminal velocity is a type of constant velocity. We say, I say this word. Okay. The person is connected to the parachute by cords as shown. Okay, let's read the question. Which of the following is the Newton's third law pairs? We have the action and reaction pairs to the force of the cord on the parachute. The Newton's third law has many conditions. Firstly, the forces for the action and reaction, by the way, forces should be from the same type. So when you add a tension force, the other one, the action and reaction. The action, when the action is tension, the reaction must be tension. When the action is gravitational, the other one should be a gravitational, and so on. Okay. To the force of the cord on the parachute. So he asked about the force of the cord, which is a type of a tension force. The force of the cord is a tension. So first one should be wrong because the air resistance is not a tension. The last one, the weight of the person, is wrong also because it's not a tension force. And second condition, they should be at the same time. And the third one, same time, but we won't use this condition in our problem. Third one will be they must act on the same object, which is the parachute, by the way, the whole parachute, the parachute balloon, and or the cloth or the material that the parachute made from, and also the cords. Okay. So the first force is the force of the cord on the parachute. It is the pair. It's the action. And we need the reaction. It should be the force of the parachute on the cord. So it will be letter C. Because B, the force of the cord on the person. So the action and reaction should be from the first object to the second one. And the reaction should be from the second one to the first one. So it's from the cord, first one, on the parachute. So it should be from the second one, the parachute, on the cord, on the first one. Okay, so it should be letter C and B will be wrong. Let's move to the next one, question 8, and say Bismillah. A student applies a tensile force of to a metal wire of length X. So it is the length of the wire and the cross-sectional area A. The extension of the wire was delta X. So it is the extension. The students apply the same force to a second wire of the same material. So we have two notes for this part. So the first one will be F is a constant value for two wires, which means that force acting on the first wire will be equal to F acting on the second wire. and the same material, which means that the Young's modulus will be also constant, means the Young's modulus for the first one will be equal to the second wire. So Young's modulus will be constant. The extension of the second wire will be delta x over 2, which means that it's half the first wire. Which row of the table could show the length and the cross-sectional area of the second wire? From the formula sheet, we have the Young's modulus equal to stress over strain. We have the stress equals to force divided by area, while the strain will be equal to the length, the extension delta x over x. So let's substitute in this formula. We have E equals to force divided by area, and second one will be delta x over x. The numerator of the numerator will be a numerator, so it will be x here. Okay, so let's make a ratio between the two wires. We have the extension is constant, and the Young's modulus is constant. So delta x, we can make a replacement between both of them. So we have delta x, I will move it here, f x a, and then I will move e to the other side. So f and e are constant. F and e are constant. So delta x for the first wire will be equals to delta x. Delta x of the second wire will be equal to delta x divided by 2, which means that we need to add here for delta x 2 or divided by 2. So the ratio between x and a should be divided by 2. X, which is the length, divided by a, which is the area, should be divided by 2. So the first one, we can add a third column. The ratio between x and a, x over a. X is x, a is half a. So the ratio, add half in the denominator, so it will be 2. Wrong. X divided by 2a, so it adds half, so it's the correct answer. Third one, 2x divided by half a, so it's equal to 4. Wrong. D is equal to 2x divided by 2a, so the ratio will be 1, and also it's wrong. So the correct answer will be letter B, x over 2a, to add the same force on different wire, made of the same material, and gives half the extension, means that the ratio between x over a should be halved, and then we should move to the next one and say Bismillah. The force extension graph for a spring is shown. It's a relation between force and extension. Take care that the force should be measured by Newton, while the extension should be measured by millimeter. Here is measured by millimeter, so you should convert into meter. From our notes, you should convert from millimeter to meter by multiplied it by 10 to the power of negative 3, which is equal to divided by 1000. Okay, so a tensile force of 50 Newton is applied to the spring. Where is the 50? Here we have 0, and here we have 100, so it will be 50. Add the mid distance between them. Okay, so at 50 we have the 1 millimeter extension. So firstly, he asked about what? Force or energy? Energy, elastic strain energy. We know the formula of the elastic strain energy, half F delta X. Delta X, by the way, is the extension. Okay? Okay, so in the first case, it's half. The force will be equal to 50. and then the extension will be 1 multiplied 10 to the power of negative 3. He asked, by the way, for the final, not the final answer, he asked about the show your work, okay? So it's the elastic strain energy in the first case. An additional tensile force of 300 Newton is then applied to the spring. Okay, so we have the elastic strain energy in the second case will be half multiplied by, we have 50, and then we add on the 50 Newton 300, so the total force will be 350. From the graph, we have the 350 in the mid distance between 300 and 400. It will be on, will be on 7 millimeter. So it will be multiplied 7 times 10 to the power of negative 3. Okay. He asked about what? Which expression gives the change in the elastic potential energy? So we need to find delta. Delta elastic strain energy equal to elastic strain energy 2 minus elastic strain energy 1 equals to half multiply 350 times 7 times 10 to the power of negative 3 minus half times 50 times 1 times 10 to the power of negative 3. Okay, let's substitute here. Can any one of the answers contain the same value? No. Okay, so half, I can take half as a common factor, and 10 to the power of negative 3. So I take this one from both sides, and 10 to the power of negative 3. Okay, so 7 minus 1, 7 minus 1. Then I already take 7 and minus 1. So the remaining part will be 350 and 50. 350 and 50. The negative is already taken with 7 minus 1. So half multiply 7 minus 6 will be equal to, or we can write 2 in the denominator, which is half. 7 minus 1, which is 6, multiply 10 to the power of negative 3. So I already take all of them. 350 plus 50, oh, we can use it. 300 plus 50 plus 50. So the correct answer will be letter C. Okay, you got this one. 350 plus 50 is 300 plus 50 plus 50. Firstly, you can write 350 is 300, which is the additional force, plus 50, which is the original one. And then times 6 times 10 to the power of negative 3 over 2. So the correct answer will be letter C. Last one in MCQ questions, and question 10, let's say, Bismillah. A student hangs a 3 kilogram mass and a 2 kilogram mass from a spring as shown. The forces on the 3 kilogram mass are in equilibrium, which means that the upward force will be equal to the downward force. Upward force equal downward force. Okay, so what's the upward force? It is the force from the spring, so it will be Kx equals. What's the downward force? The downward force will be the weight of the 3 kilogram object and the tension force from the 2 kilogram. The 2 kilogram has two forces acting on it. The first one will be downward mg, mg, and the upward one will be 2g. So the 2 kilogram attracts, or it make like a tension force on the 3 kilograms, so it pulls down. And then the 3 kilogram acted by 3 forces. The first one will be the spring force, which will be upward force equal to kx. Downward force, firstly, will be its weight, 3g mg, because the weight is equal to mg, plus the tension force from the 2 kilogram, which pulls it down. Yani we have the 2 kilogram object attracts or pulls the object, the 3 kilograms, downward. So it has a force of 2 kilogram, or 2g, sorry, mg. 2 kilogram m multiplied by the gravitational field strength. So we have kx will be equal to 5g. It's the first one for the 3 kilogram object. Then the string holding the 2 kilograms mass breaks. So you should remove the 2 kilogram object. Which expression gives the initial upward acceleration? Okay, so at the moment when the 2 kilogram object spring breaks down, we have the spring will apply a force that returns the object of the 3 kilogram to the equilibrium position. It pulls it up. Okay, so we have the spring will attract the 3 kilograms to upward direction, to the upper direction. Okay, then he asked about the initial upward acceleration, which means that he asked about the at the moment. Yani the spring doesn't apply the force yet. Okay, so we have the expression that applies or that expresses the acceleration. We have the acceleration equals to the force, net force, divided by the mass. The mass of the 3 kilogram will be equal to 3. The net force, we have downward force of 3g, because the net force will be F upward, sorry. We have the upward force, F upward, minus F downward. Because he asked about the upward acceleration. So we suppose that the upper direction will be the positive, because the direction of motion of the 3 kilogram after the spring of the 2 kilogram or the string of the 2 kilogram is breakdown. So the motion will be upward. So it will be the positive direction. 3. The upward force will be initially will be kx. Yani because the object or the 3 kilogram, it doesn't move yet. Minus the downward force will be mg of the 3 kilogram, so it will be 3g. So the acceleration 3 kx, you can substitute it by 5g, because the 3 kilogram initially, at the moment of breaking down the string of object 2 kilogram, the 3 kilogram object, it does not move yet. Minus 3g. 5g minus 3g, it will be 2g over 3. And so the correct answer will be 2g over 3. It will be letter A. Let's move to the next question. Section B. Okay, a car accelerates from rest, which means that the initial velocity will be equal to 0 on a horizontal road. So the car will move to the right or to the left. The engine causes a forward force of F on the car of 7,500 Newton. So there is a forward force of 7,500 Newton. The weight W of the car is 15,000 Newton. So it is a downward force, which is the gravitational force, and it's called the weight, which is 15,000 Newton. Okay, which is double, by the way. Yani it's double the forward or the engine force. The road exerts a normal contact force N on the car, as it's equal to the weight. Yani the weight is 15,000 Newton. and the normal force will be 15,000 Newton, which is equal to the weight, but it will be in opposite direction to the weight. Complete the free body diagram for the car at the instant the acceleration begins. Okay, so we have three forces. The first one is the gravitational force or the weight, which is downward force. We can draw it by 1, 2, 3 lines. Okay, it is a downward force. 15,000 Newton, and it's equal to the weight. Equal to the gravitational force, there is equal but opposite force, and it will be an upward force. 1, 2, 3. And it's called the normal force, 15,000 Newton. Okay, it is a normal force. And we have the last one, which is the forward force, 7,500, which is half the weight. So we will move to 1 and half. Oops, 1 and a half. So I will move this one upward. Oh, sorry. I will draw it another time. Okay. So it will be forward for 1 and a half the distance. I will delete this one and I will draw it here and then move it. Okay. So it will be 1 and a half the distance. So it will be 1 big square, 2, 3. So this one will be 1, 2, 3, half this distance. So it will be 7,500 Newton, and it's called the forward force or the engine force. Okay, so it will be half the distance or half the vectors that represent the normal or the weight. So firstly, you should make like analysis for all the forces and write all of them and deduce each the direction of each one of the forces, and then draw them with your pencil and ruler, and make sure that all the lines must be straight. The line is not thick. Also, the equal forces should be exactly equal to each other. Then let's move to the next question and say Bismillah. A crane lifts a load of 3,400 Newton, so we have the force, through a distance of 26 meters, so it is a distance, which is S, by the way. The power input to the crane is 5.7 kilowatt. In order to convert from kilo unit to the unit, which is watt, you should multiply by 1000 or multiply 10 to the power of 3. The efficiency is 0.38. Calculate the time taken for the crane to lift the load. So from the data booklet or the formula sheet, we have the formula of the efficiency. It's equal to the ratio between the output useful power over total input power. So we can substitute in this formula. We have the efficiency 0.38, the output useful power, we don't know this one, and the total input power, we have it equal to 5.7 multiplied by 1000, which is 5,700. So we can get the useful power, which we use to move the load, equals to 5.7 multiplied by 10 to the power of 3 or 1000 multiplied by 0.38. So the useful power is equal to, I will use my calculator, times 1000 times 0.38. It will be 2166 watt. Okay, it is a useful power. And you know that the power, we have the formula, power equal to the work done divided by the time. So I will make a replacement between the time and the power. So I will move the time here to be equal to the work, and I will move the power here over power. The work done, we have the formula of the work, which is equal to force multiplied by the displacement. Force equal to 3,400. The displacement or the distance moved is 26 meter, divided by the useful power, which is 2166. So we can find the time. I will make a ratio 3,400 multiplied by 26 over 2166. It will be equal to 40.81 second. So you can write it to be 40.8. Okay, so this is for the question 12 in this exam. Okay, let's move to question 13 and say Bismillah. In a game called curling, player slides circular stones across ice toward a target. We have the ice means that the dissipated energy as a friction or as a heat or as a sound will be neglected. So there is no power lost or there is no energy lost. In one game, stone A moves towards the target and stone B is stationary. So we have the velocity of stone A is towards the right, which is a positive direction, and stone B has an initial velocity equals to 0. Stone A is about to collide with stone B as shown. During the collision, there is a resultant force on stone A and the resultant force on stone B in the opposite direction. We know that from Newton's third law, when for every action there is a reaction equal in magnitude but opposite in direction. So stone A applies a force on stone B, and stone B will apply an equal but opposite force on stone A. These forces have the same magnitude, so the force is constant, and act for the same time, so we have the time is also constant. So we have the force acting from stone A at stone B equal to the force acting from stone B on stone A, and both of them act at the same time. So we have the two forces acting on the same time. So firstly, we can say, he asked about explain how Newton's second law predicts that the momentum is conserved when stone A collides with stone B. You can mention this point. When stone A collides with stone B, then you can write velocity of stone B will increase while the stone A decreases. Okay, because stone B is stationary, so when stone A collides with stone B, velocity of stone B will increase while the velocity of stone A will increase. So we have equal but opposite change in their momentum. Why? Because the force acting from stone A on stone B multiplied by the delta T, which is the time, equal to the force, the magnitude of the force acting from stone B on stone A multiplied by delta T. It's equal but opposite. So we have the change in the force multiplied by delta T equal force multiplied by delta T. So we have the from Newton's second law, from Newton's second law, that the force is the change in object momentum over the time. So the momentum, change in momentum from stone A equal to the change in momentum in stone B. So explain how Newton's second law predicts that the momentum is conserved, because the force multiplied by delta T equal delta B, so momentum will be conserved. Okay, this is for the part of point A in question 13, and then let's move for part B. Part B said that before the collision, stone A had a kinetic energy. We know that the formula of the kinetic energy, half mv square. Okay, and it's before, so we can write it u squared because it's before the collision. Okay, so the formula of the kinetic energy, 3.8 equals half multiplied, we need the stone A, so we need mass A or initial velocity of object or stone A squared. Stone B was stationary, so we have the kinetic energy equals 0 for stone B, and kinetic and the momentum will be equal to 0 for stone B. After the collision, stone B moved with with a speed of 0.45 meter per second. So we can find the kinetic energy for stone B. I just write like the given that he gives you in the question. Kinetic energy of B equal half mass B velocity B squared. Okay, so you can find the kinetic energy of B equals half multiplied by mass B, and he give you the velocity, which is 0.45 squared. So you can find the kinetic energy of B, and also you can find the momentum, which is mv. So it's for B. So momentum B equal, we need the mass, and the velocity, by the way, is 0.45. Okay, stone A will slide past the target if the momentum of the stone A after the collision greater than 5.5. if the stone A gains a momentum, loses its momentum, and the part of its momentum, the remaining one, is 5.5, the remaining momentum after the collision in stone A. We have stone A collide with stone B. Okay, stone A, due to its motion, and already it has a mass, so it has a momentum. So when stone A collide with stone B, it will lose its momentum or a part of its momentum. He mentioned this condition: if stone A, the remaining momentum in stone A greater than 5.5, it will be after the target. Deduce whether stone A will slide past the target, so we need to find the momentum of A after collision. Okay, and he give you, by the way, mass A and mass B, so we can substitute here. We have mass A, which is 18, and we need velocity of A, initial velocity of A, so we can find it equal 3.8 over half multiplied by 18. You can move half multiplied by 18 to the other side by division. Okay, so and then you can get square root. So I can find the initial velocity of A. I will use my calculator. Square root ratio, 3.8 divided by half times 18, which is 9. I got it 0.649. By rounding the value, it will be 0.65 meter per second. Okay, so here is the initial velocity of A, and then he needs the momentum after. The momentum is always conserved, so we have momentum A plus momentum B, both of them before the collision, equal to momentum A plus momentum B after the collision. Okay, it's called the conservation law of momentum. Momentum A before collision, it's M multiplied by V plus 0, because object B or stone B was stationary, so it has no velocity, and so it has no momentum. Momentum A after collision, we need it. Momentum B after collision, we have okay, so it's 18, sorry, it's 17 multiplied by 0.45, 7.65 kilogram meter per second. Okay, so it's 7.65. So I need momentum A. So I will calculate 18 multiplied by 0.65 minus 7.65. Let's calculate it. 18 multiplied by 0.65 minus 7.65, I got 4.05. So momentum A after the collision, it will be 4.05 kilogram meter per second. So I will compare between this momentum and the momentum in the question. He told you that if the momentum exceed greater than 5.5, it will exceed. So it's less than 5.5. We can write, so stone A won't slide after the target. Okay, and you can write yani by your way in the question, in the test, in this part only. Let's move to the next one and say Bismillah. A container is used to hold plants. The container hangs by a chain from the bracket attached to the wall as shown. So we have, here is the wall, okay, and we have a hook and a chain where the container is hanging from it. Okay. The bracket has a horizontal bar with a hook at one end. There is a supporting bar beneath the horizontal bar. So we have the supporting bar and the horizontal bar. Okay. A. The container is in equilibrium. What's the idea of mention the part that the container is in equilibrium? It means for you two important things. First one, the net force acting on the container will be equal 0, which means that the horizontal components are equal, which means that the right equals the left, and the vertical components will be equal to each other, which means that the upward force equals to the downward force. Second part, the principal law of moments, which means that the net momentum will be equal to 0. Okay, so it's very important word. Okay, state why the center of gravity. Center of gravity is a point where all the weight of the object will act. Of the container is vertically below the chain. The center of gravity of the container vertically below the chain. Why it's at this point? State why. Because he mentions that the part, because, yani you can write this word, because the container is in equilibrium, so the clockwise moments equal to the counterclockwise moment, or you can mention that as the mark scheme, by the way. The net momentum, the net moment equals to 0. Equals 0. So the we have a geometrical shape. So the center of gravity will be in the mid distance between the right and the left, because the net moment acting on it will be equals to 0. Let's move to letter B and change the color. A screw in the wall exerts a force F. We have here the screw, okay, on the horizontal bar, on this one. Here is the horizontal bar. Here is the horizontal bar, okay? Okay, as shown, the weight of the container is 34 Newton, so we have the force acting on the horizontal bar downward will be 34 Newton. The mass of the bracket, by the way, is negligible. Determine the force F. He asked about the force F, where you should take the moment about the pivot at point B. Okay, so you can mention the principal law of moment, which states that principal law of moments, which states that the clockwise moments equals to the anti-clockwise or the counter-clockwise moments. Okay, let's move to apply this one. Where is the clockwise moment? Here is the pivot, point B. So the force F will apply in this direction. You can know which one is the clockwise and which one is the counterclockwise by drawing a circle from the point of the force and make the pivot as the center. So it will rotate in counterclockwise. So it's in the part of the counterclockwise moment. So we can apply it in the counterclockwise. So we have the force multiply. By the way, the formula of the moment is the force multiplied by the perpendicular distance from the pivot till the line where the force will act. Okay? So here is the force and here is the pivot. So we need this perpendicular distance between them. Okay, we have the angle 55 and we have the opposite. And the distance that we need is the adjacent. So you can use 10, 55 will be equal to the opposite, which is 0.16, divided by the adjacent. The adjacent will be the distance. So use the replacement. Distance equals 0.16 divided by 1055. So we have the distance. I will use my calculator. 0.16 divided by 1055 will be equal to 0.112 meter. Okay, so it will be 0.112 meter. And here is the other force, which is the weight, and it rotates in clockwise. Here is the force, it's moved downward. Okay, it's moving downward, and then it will rotate in the clockwise. So it will be 34 multiplied by the distance between the line, the pivot, and the line where the force will act. So we need this distance, which is equal to 0.28 meter. 0.28. So the force will be equal to 34 multiplied by 0.28. I just rearrange the formula, the equation. 34 multiplied by 0.28 divided by 0.112. 112. So the force will be equal to 85 Newton. So it will be 85 Newton. Let me check the mark scheme. Yes, it's 85. Let's move to the next question and say Bismillah. Okay, for this question, a can of spray paint contains a paint and a solvent, which are both liquids. The can also contains a ball bearing, which is a solid substance. It has a smooth surface, so the friction force is it's very small. Okay, when the can is moved, the ball bearing moves through the paint, so we should apply Stokes' law. Stokes' law is a principle in fluid mechanics that calculate the drag viscous or the drag force acting on a small spherical particle or a small spherical object moving through this viscous liquid. Okay. When the can is moved, the ball bearing moves through the paint. Okay. Through the paint, a Stokes' law applies as the small bearing moves through the paint. State the conditions. Okay, state the conditions for Stokes' law to apply, and we know that we have three conditions for applying Stokes' law. First one, the object should be. It's a standard question, by the way. Object should be small and has spherical shape. It's the first condition. Okay, we can make zoom in. Second condition, the object should move in lower, the spherical object should move in lower speed to allow the applying the condition of the laminar flow. So the object should move in low speed to apply the axis of laminar flow, and we can make the laminar flow in the third condition. Presence of laminar flow, and its flow through the fluid will be laminar, which means that the absence of the turbulent flow. Flow. Here is the condition, and here is, by the way, the mark scheme. Next one, Stokes' law applies as the ball bearing moves through the paint at a constant speed or constant velocity. The formula that you can apply when you see or when the question is asking or told you about the constant velocity or constant speed is the velocity equals to distance divided by the time. Okay. The ball bearing moves a distance of 5.6, so we have the distance 5.6 divided by 100, because the if you want to convert from centimeter to meter, you can multiply it by 10 to the power of negative 2 or divided by 100 in a time of 1.3 seconds. So we can get the velocity by meter per second. So it will be, I will use my calculator, 5.6 divided by 100 over 1.3, so I get the velocity to be 0.0430769, which is approximately 0.043 meter per second. Then calculate the viscous drag. The formula from the formula sheet. The force or the viscous drag is 6 by eta, which is the symbol or Latin letter for the viscosity coefficient of the paint or the fluid, r, which is the radius, v, which is the velocity. Okay, so we have the force 6 by eta is 0.15 Pascal dot second, and it's the SI unit for the viscosity coefficient. R, which is the radius, but it's given in millimeter, so you should multiply it by 10 to the power of negative 3. Multiply the velocity, which is 0.043, and then you should use your calculator. 6 by, make sure your calculator, when you use the symbol by, in degree, not rad, the letter D, not R on your calculator, or instead you can use it by 22/7 or 3.14. 0.15, 0.9. Right now I'm using my calculator. 0.043. So the answer will be 1.0942 multiplied 10 to the power of negative 4, and the measuring unit will be Newton. So we can write it to be 1.09 multiplied 10 to the power of negative 4 Newton as the mark scheme. Next one. C. When the can is shaken, the ball bearing move. Okay, this causes the paint and the solvent to form a mixture. The viscosity of the mixture is different from the viscosity of the paint. The ball bearing, because we change the material, the ball bearing falls through the mixture at terminal velocity. What's the meaning of terminal velocity? Means that two things: the force or the net force equal to 0, which means that the upward force equals the downward force, the right force equals the left one, and the acceleration will be equal to 0, and you can use the formula velocity equal distance over time. Calculate the viscous drag, because the viscosity changes, so the viscous drag will also change due to the mixture on the ball bearing. So we have the ball through the fluid. We have a downward force, which is the weight, and because he told you that it falls, and the upward force, we have two forces. First one, it will be the upthrust, and second one will be the upthrust from the liquid due to the movement through the fluid, the movement of the ball bearing through the fluid. And the next one will be the drag force, and he asked about the drag force. So as the ball bearing moves at terminal velocity, you can write F net total force equal to 0, which means that the drag, the upward force, plus the upthrust equals to the gravitational force or the weight. So the force of the viscous drag, it's the needed force of drag. Upthrust force, it's density, volume multiplied by the gravitational field strength. Density of the fluid, volume of the displaced water due to the placement of the ball bearing, which is, by the way, the same as the volume of the ball bearing, equals to the weight, which is the mass of the ball bearing multiplied by the gravitational field strength. I will substitute right now. Force of drag, which is needed. Density of the mixture, it will be 1.5 multiplied 10 to the power of 3. Volume of the ball, we have the shape of the ball is a spherical shape, so it will be 4 over 3 multiplied by 22 over 7 multiplied by, we have the radius of the ball bearing, which is 0.9 times 10 to the power of negative 3 all power 3 multiplied by 9.81, sorry, and then equals the mass of the ball bearing. We have it's 2.4 multiplied 10 to the power of negative 5 multiplied 9.81. So I will find each part separately. So the force of drag, here is the force of drag, equals 1.5 times 10 to the power of 3. Right now I'm calculating this part, okay, and I will write it here. 1.5 times 10 to the power of 3 multiplied by fraction 4 over 3 multiplied by 22 over 7. I open the bracket, 0.9 multiplied 10 to the power of negative 3, close the bracket, all power 3 multiplied 9.81. So I have the, it's plus 4.49, which is 4.5 times 10 to the power of negative 5. Currently, or right now, I will find the last one after the equal formula or equal sign. 2.4 times 10 to the power of negative 5 multiplied 9.81. I got 2.35 times 10 to the power of negative 4. So I will rearrange my formula. I will move this one to the other side. So the force of drag equals 2.35 times 10 to the power of negative 4 minus 4.5 multiply 10 to the power of negative 5 minus 4.5 times 10 to the power of negative 5 equal, I got 1.9044, so it will be 1.9 multiply 10 to the power of negative 4 Newton. 1.9, sorry, 1.9 times 10 power, I have 10 power negative 4 Newton, so 1.9, okay, times 10 to the power of negative 4 Newton. So it is the correct answer for question 15. Let's move to the next question and say Bismillah. In this question, we have the photograph show a tennis racket. A student determined the Young's modulus of the material of the string from a tennis racket. She used the apparatus shown below. He used the clamp and the string, and by the end of the string we have the pulley, and then it's attached to the small mass. Okay. The students determine the cross-sectional area of the string. Okay. If you want to find the Young's modulus, so it will be equal to the ratio between the stress over the strain. So to determine the stress, you need the force acting on the wires, tension force, and also the cross-sectional area. So the students measured the original length and also determined the cross-sectional area. She measured the original length of X of the string between the clamp and the marker. Between the clamp and the marker. Okay. She increased the tension in the string and measured the new length of the string between the clamp and the marker. She used her result to calculate the Young's modulus of the string. State why. State why the student should suspend a small mass. He should use this small mass from the string before measuring X. So we need a reason for why he used this mass. We use this mass in order to make the string tension or stretched, or we need to allow the wire to be straight. Okay, so to make the wire straight, there is no strain, there is no like any curves part in the wire, so it will be the one mark to make the wire straight. So we use a small mass, so its force will be downward and the tension force will be in this direction through the wire. Okay. Second one, explain how the students could decrease the percentage uncertainty in the value of X to decrease the value of measurement value. So we need to decrease or to reduce the parallax error, which is the error or a type of inaccuracy that occurs when you read a measurement scale from an angle rather than directly from straight on. Okay, so we need to reduce the percentage uncertainty or the reduce the parallax error. Okay, so firstly we put the ruler in a horizontal position. I will show you how to put the ruler. We will put the ruler in a horizontal position with using set square like this one. I will get back and I will use my ruler. So we put the ruler in this part and then we use the set square to measure the X like this one. So we need to reduce the uncertainty. I will hide my ruler. Okay, so the second point is after using the set square to reduce the parallax error, and when the parallax error reduced or decreased, the uncertainty will decreased. Okay, so when you measure the value of x, which is the length, we need a ruler to measure the length. And in order to decrease the uncertainty or the percentage uncertainty, we need to use the ruler with set square. After using the ruler and set square, you get an accurate value. Okay, and after it, why we use the ruler? In order to reduce the parallax error, and after that you will decrease the uncertainty value. Third one, and the last part in this question, he tell you that the table shows the Young's modulus of different materials used to make string for tennis racket. We have the gut, the Young's modulus is 6 gigapascal, nylon, which is 5 gigapascal, polyester, which is 0.92 gigapascal. And by the way, gigapascal to pascal, or giga unit to unit, by the way, it will be 10 to the power of 9, and the adverse process will be 10 to the power of negative 9, or divided by 10 to the power of 9. The string used by the students has had a cross-sectional area of 1.2 multiplied 10 to the power of negative 6 meter square, and the initial length of the string is 1.6. So we have x and we have the area. When the students increase the force by, so we have delta F. The length of the string increased by, so we have delta X. So firstly, we should measure sigma, which is the stress, which is delta force, change in force over the cross-sectional area. So it will be 15 divided by 1.2 multiplied 10 to the power of negative 6. 15 divided by 1.2 multiplied 10 to the power of negative 10 power negative 6. So I got 1.25 multiplied 10 to the power of 7 Pascal, or Newton per meter square. By the way, it's the same measuring unit as the pressure. And next one, we will find epsilon, or the strain, which is the change in length, or the extension or increase in length, divided by the original length. So we have 4.2 multiplied 10 to the power of negative 3, which is delta x, and it's measured by millimeter. To convert from millimeter to meter, or milli-unit to unit, you should multiply the 2 by 10 to the power of negative 3. And then x will be 1.6. Then I will get 4.2 using my calculator. 10 to the power of negative 3 divided by 1.6. I get 2.625 multiply 10 to the power of negative 3. And don't forget that it's unitless. It has no unit, because it's the ratio between two similar physical quantities, length and length. And then we should find E, which is Young's modulus. Stress over strain. Stress is 1.25 multiplied 10 to the power of 7 divided by 2.625 times 10 to the power of negative 3. Using my calculator, it will be 2.625 times 10 to the power of negative 3. I got 4.76 multiply 10 to the power of 9, and it's the same as Pascal. So to compare it to these values, you should convert it to gigapascal. So E equal to 4.8 approximately gigapascal. So it's nearly equal to nylon. So it's nylon. And let's move to the next question and say Bismillah. In a factory, boxes move along a track. Here is the boxes, and they move along the track. Okay. One track forms an inclined plane at an angle of 22 to the horizontal. A box of mass 5 kg is placed on the track as shown. The box slides down the track from rest. Friction acting on the box is negligible. Calculate the velocity of the box when it's moved 2.5 meter. Okay, so when the box is moved downward, we have the conservation law of energy. The conservation law of energy, which states that the gravitational potential energy stored in the box when it's placed at the specific height or at the maximum height will be converted into the velocity or the kinetic energy when it reaches the ground. All the gravitational potential energy will be converted into kinetic energy. So the kinetic energy at the top plus the gravitational potential energy at the top will be converted into the kinetic energy at the bottom plus the gravitational potential energy at the bottom. Okay? At the top, the object is at rest. He mentioned that. Yes, the box slide down the track from rest, which means that the kinetic energy will be equal to 0 at the top. Plus, the gravitational potential energy will be mgh. Here is the height. Equals the kinetic energy at the bottom will be half mv square plus the gravitational potential energy at the bottom will be equal to 0 because there is no height between the object and the ground. So we can write mgh equals to half mv square. In the test, you shouldn't write all of this stuff, okay? But I write to explain to you. So you can skip m with m. G is 9.81 multiplied by the height. We need to find the height. The length of the track is 2.5 meter long. So we have the 2.5 meter. And here is the right angle. So from sine theta, I will write it here, downward. Sine at this part. Sine 22 equals to the opposite, which is the height, divided by the hypotenuse, which is 2.5. So the height equal 2.5 multiplied by sine 22. Using my calculator, 2.5 multiplied by sine 22, I got the height equal 0.936 meter. 0.936 equals to half multiplied by v square, and I need the v square. So we have v square, I multiplied it here, 2 multiply or 9.81 multiply 0.936 divided by half, and then I will get the square root. So square root, fraction, 9.81 multiplied by the answer divided by half, it will be 4.286 meter per second. So it will be the velocity 4.29 meter per second. Okay, here is a part of the question 17a. We use the conservation law of energy, which states that the total energy at a specific position equal to the total energy at another position when it's a closed system, when there is no energy will be dissipated to the surrounding. Let's move to the next part, the star question. The box is placed on a different track in the factory. The sketch graph shows how the displacement of the box varies with the time. We have a displacement time graph between it's 3 interval, from 0 to 10 and from 10 to 20 and from 20 till you can reach 30. Explain what the graph show about the velocity and the acceleration. Firstly, this graph is between the displacement and the time. We don't have anything for or related to the area. So we have the gradient. For each graph, you should start with this point, the gradient or the area. The gradient of the line represent what? Displacement over time. It will be equal to the velocity. So the gradient of the line represents the velocity. because it's displacement. Second part, it's the first one. Second one, you should represent each part from 0 to 10 seconds. We have its straight line. Here we have its straight line. Okay, so the line is straight, which means that the velocity, the line is straight, so which means that the gradient is constant. Firstly, the gradient is constant, and so the velocity, which is equal to the gradient represents the velocity. So when the gradient is constant, and so the velocity is constant. As if you want to find the gradient at any 2 points, you will get the same value. Okay, that means that which means that the gradient is constant. And from 0 to 10, the acceleration is 0, because we have the velocity is constant, and when the object is moving with constant velocity means that the acceleration is 0, because the acceleration is the rate of change in object velocity, and here there is no change in velocity, so the acceleration will be equals to 0. Let's move to the next part, from 10 to 20, from the 10 second till the 20 second. The gradient, let's see what happening to the gradient. If you want to find the gradient here is the gradient. Okay, tangent to the line. If you want to find another gradient here, the gradient is decreasing, or the angle between the line and the horizontal line is decreasing. So we have the from 10 to 20, the gradient is decreasing. If you want to mention the gradient is decreasing, or it will be a smaller value or reduced, it's correct. So the gradient is decreasing, means that the velocity decreasing or decreases. Okay, and then from the same interval, from 10 to 20 seconds, the acceleration is negative, or you can write that the acceleration, the object is decelerate. Okay, we don't have any other space. I will reduce my line or decrease its the font. Okay, sorry. Okay, then what happened at the 20 second? I will draw the tangent. It's parallel to the time axis, which means that the object is static at the 20 second. We can write it at 20 second, at exactly 20 second, the gradient is equal to 0, and so the velocity will be equal 0. Okay, and the acceleration will be equal to 0. It's for the 20 second, or at 20 second. From 20 to 30, from 20 to 30, let's explain what happened. We have a negative slope or negative gradient, which means that the object is returning back to the starting point. We have here the object is static, and then it accelerates, or it will returns back to the same starting point, because the displacement will be with negative, because the object, if you complete it, it will returns back. Okay, so we have after 20, we can write it here or at, no, it's another question. We can write it here. After 20 seconds, the object begins to accelerate, but in opposite direction, because the displacement will be negative, and then the gradient will increase. Here we have a gradient 0 because the object is static, and then the gradient is increasing till the object will accelerate till it reaches the starting point another time. So we have after 20 seconds the object begin to accelerate, but in opposite direction to the original one, because if you want to calculate the displacement, it will be negative, and negative displacement means that the object, if the first part the object moves to the right, then it will become negative, which means that it returns back to the same starting point, but in opposite direction, and the object looks toward the start point. Okay, here is a perfect 6-mark question. Let's move to the next question and say Bismillah. In 2009, a satellite orbiting the moon fired a projectile towards the surface of the moon. The initial velocity of the projectile is 2460. So we have u, which is the initial velocity, equal to 2460 meter per second. Okay, at an angle theta to the horizontal. So we have to we should resolve the initial velocity to ux and for negative uy because it's downward. The horizontal distance traveled by the projectile is 2930 meters, which is called the range. The time taken for the projectile to reach the surface of the moon was 7.5 seconds, shows that theta was about 81 degrees. For any projectile question, you should split the paper to two sides. The first one is the horizontal, because in the projectile motion it's two-dimensional motion, and second one is the vertical one. You should know that in horizontal the object moves at constant velocity, the velocity is unchanged, and the acceleration is equal to 0 in the x-axis or in the horizontal dimension with negligible the air resistance. Second one is the vertical, so the object move under the effect of the acceleration due to gravity, so it's uniform or constant acceleration. And here we have the acceleration in the y will be negative g, or the negative of acceleration due to gravity, which is 9.81, or if you add another planet like the moon, yes, it's at the moon, so it will be the acceleration due to gravity of the moon, okay, or the gravitational field strength of the moon. In the part of the horizontal, you should use the part or the equation or the formula of the constant speed, which is the distance equal ux multiplied by the time, okay, or the whole time. We can write it as T capital, the whole time or the time for the full trip. In the part of the vertical or the constant acceleration, you can use the SUVAT, which is the kinematic equation of motion when the object moving at constant speed. Sorry, at constant acceleration, okay? So he asked about the angle, which part you have all of its information, the horizontal or the vertical. We have the range 2930. Ux, it will be u cosine theta multiplied by t. Oh, you have everything. Okay, So we have the range 2930. U, which is the initial speed, it will be 2460. 2460 cosine theta multiplied by the t, which is the time taken from the moment of projection till it reaches the ground, which is the whole time 7.5 seconds. So I need cosine theta. So it will be 2930. I will rearrange this formula. 2460 multiplied by 7.5, and then to get theta I will make the adverse of cosine. So it will be, I will use my calculator right now. Shift cosine 2930 over 2460 multiplied by 7.5. It will be equal 80.86 degree, which is approximately equal to 81. Letter B. Calculate the speed of projectile at it reached the surface of the moon. When it reaches the surface of the moon, he asked about the whole the final velocity. So he asking about the speed, not the horizontal, not the vertical. So in order to find the speed at any moment, at the moment of reach the surface of the moon, so we need the square root, because it's the resultant between the horizontal one and the vertical one, Vx and Vy. So we need V. So we will use a formula of the vector addition for two perpendicular forces, or two perpendicular, vectors. So it will be square root Vx square plus Vy square. So to find Vx, it's equal to Ux, because horizontally, when the object moves horizontally, it will be moving with constant speed or constant velocity. So it will be Ux, which is U cosine theta. U is equal to 2460 cosine 80.8. I think it's 80.86, right? Right. 86. So Vx will be 2460 cosine the answer. So it will be 390 meter per second. While Vy, we have the time to reach the ground, and we have the acceleration, and we have the initial speed and the angle. So we can find it by using the first kinematic equation, V equal U plus AT. So it will be Vy equal Uy plus GT. So it will be negative downward, and G will be negative. So negative 2460 sine, it's Uy, U sine theta, sine 80.86. The velocity will be downward negative, and the acceleration due to gravity will be also negative. Minus 1.63, and the time will be 750. 7.5. I will find it and then substitute in this formula. Vy negative 2460 sine 80.86 minus 1.63 multiplied 7.5. I get to negative 2440.99, so it will be 1 meter per second. Then I will substitute in this part. So it will be square root Vx is 390 square plus Vy negative 2441 square, and then I will write the final answer here. Okay, square root answer square plus 390 square. I get 2471.9, or we can write it as 2 meter per second. I got 247.1.94. Okay, so by rounding it, it will be 2472. Next one. A satellite orbiting the Earth could fire a projectile towards the surface of the Earth, so he replaces the planet. Firstly, it will be it was the moon, and now it will be the Earth with the same initial height. So we have h is constant, then and velocity, so v is constant, as the projectile fired toward the moon. So it will be as the same angle, I think. Okay. Students use the equation of motion to predict the motion of this projectile. Explain how the predicted horizontal distance traveled by the projectile would be different from the horizontal distance traveled by the moon. Okay, assume that the acceleration due to gravity is constant and has a value of 9.81 meter per second square. You don't need to do any calculations. So what's the difference between the horizontal one and the vertical one? Firstly, we have the range. What's the factor affecting the range? The formula of the range, I write it here. It is the initial velocity multiplied by the time. So I will check what happened to the time. So firstly, you should mention that the horizontal component will be constant, because he mentions that as the projectile fired on the moon, so it has the same theta and the same velocity. So you can write the horizontal component of velocity, of initial velocity, or the velocity, by the way, of initial velocity will be the same, it doesn't change, which is ux equal u cosine theta. Theta is constant because as the projectile fired toward the moon, so it has the same way of projection. Second one, u is constant, same velocity. Okay, so it is the first point. Okay, what's the factor affecting the time? We have the range that he asked about, equal to ux multiplied by t. What's the factor affecting t? We have the formula, which is vy equal uy plus plus gt. Or we have another formula, because he didn't mention what happened to the final velocity. Second one, second equation that affects the time, which is s, so that uyt plus half gt. gt square. So we have the same height, same initial height, so it will be constant. Same angle and same velocity, so uy is constant. Okay, so the factors affecting g is the factor affecting time is g, and they are inversely proportional to each other. Okay, because you have the t, yani if you want to find t, if the vy is constant, so you will move g to the other side, so it will be inversely proportional relationship. So you can write this one. We have an inverse relation between t and g. Higher g, the Earth has 9.81 while the Moon is 1.63. So higher g means lower time. So lower time, we have the formula, r is directly proportional with the time, so less horizontal range. Okay, so it's the factor y, the horizontal range at the Earth will be different than the Moon, because the Earth has less g, more g, so it has less time to reach the ground from the moment of projection till it reaches the ground, and then when it has lower flight time, it will have a lower range. Next one. The students use the equation of motion to calculate the speed of projectile at the surface of the earth. The students use, all of us use 9.81 meter per second for the acceleration of the projectile. Give two reasons. It's a standard question. Give two reasons why the student's value for the speed wouldn't be accurate. For sure, there is an air resistance. So you can write that there is there is air that affect by drag or air drag resistance, drag force. So the horizontal component of velocity will decrease because the horizontal motion to the right, so the drag force will be to the left, which affect in opposite direction to the motion, so it will decelerate the object. So there is air resistance that affect the motion of the object by drag force, also which affects, by the way, the horizontal component of velocity that will decrease, and the acceleration, and you can mention the last one, g will faces a decrease or a decreasing in its value, as we have the object that's affects by negative g, and then when it moves upwards there is downwards there is a air resistance or drag force that affects the motion, so it will be opposes the force of gravity, so it will decrease the value of 9.8. Let's move to the next question, and question 19. A toaster is a device used to heat a slice of bread. A platform in the toaster is supported by 4 springs. I will highlight the givens. A slice of bread is placed in the toaster, and a person pushes the platform downward. So here is the bread, or here is the platform, by the way, here is the platform. It's empty right now. And after we place the slice of bread and push it downward, we have 2 forces applied to it downward. First one is the force or the work done by the weight. Second one is the work done by the person to use his finger to push it downward. Okay, so we have the weight downward and plus the work done by the person. Okay, stretching the spring, so we have the elastic potential energy or the work done by the springs is upward, so we have the work done upward, work done by springs. We have 4 springs, by the way. Here is the 4 springs. Okay, a hook then hold. Where is the hook? Here is the hook. We have a hook. Okay, what's the function of the hook? We use the hook to opposes the motion or slide it down. Okay, so we have 3 forces or 3 work done. Work done by the weight, it's downward. Work done by the person, it's also downward. And work done by the spring, it's upward. And the hook prevent the spring to move upward. Okay, so we have the work done by the spring. We avoid it to be displaced upward, so we apply the hook, or so we fix the hook. In the spring or the spring system, we use the hook to prevent its returning back to the original position, like a stopper. Okay, so we have the work done by the spring is greater than. This is due to why we use the hook. Explain why the elastic strain energy stored by the spring compares to the work done by the person to push the platform downward. We already answered this one. Okay, so we have a total or يعني we have spring or work done by spring, work done by the 4 springs, and you should mention their direction upward in order to return the toaster, or to return the bread and the platform to their original position. Also, we have a downward force or downward work done by the weight or the gravity and the finger of the person or the person. Okay, so we have 3 work done, 1 or 2 work done. One is upward by the springs and the other one is downward due to the finger of the person and the weight. So we use the hook because the elastic spring energy, which is the work done by the spring, it has the same meaning, greater than the total work done by the weight and the person finger and person. Okay, so it's the correct answer, and when you compare it to the mark scheme you will find that you will get the 3 marks. Okay, so we use the hook to prevent the the overcoming of the springs over the work done by the person and the weight. Next one, letter B. The platform is supported by 1 spring at each corner. So we have the upper view for the platform. We have here a spring, as it's 4 corners, because the platform that we will put the bread on it has a rectangular shape or square shape. The 4 springs are identical. What's the meaning of identical? They have the same stiffness, same spring constant, same K. Person placed the slice of bread of weight 0.52 in the toaster. The weight of the bread causes the platform to move distance of 2.1 centimeter downward. It's by centimeter. Don't forget to convert from centimeter to meter. You should divide it by 100. So it will be 0.020, we can write it here, delta x, which is the extension or the increase in length or the compression or the distance moved when you apply the force, equal to 2.1 divided by 100, which is 0.021 meter. Shows that the stiffness, he asked about K for each one, so I will get K total. K total equal F total over delta X. It's sorry. It's the formula of Hooke's law. So we have the force 0.52 and delta X is 0.021. I will use my calculator. 0.052 divided by 0.021, I get 24.76 Newton per meter. It is the K total for all the spring. He asked about the spring, each spring stiffness. So the K of each spring will be K total divided by their number because they are identical. So it will be 24.76 divided by 4. I got 130 divided by 22, which is 6.19 Newton per meter, which is nearly equal. K of each approximately equal to 6 Newton dot meter negative 1. Okay, so it's the answer of this question. If we will use K for each spring in the next part, we will use this one or this one for all the system, not the nearer or the rounding one. I think it's the last question. Yes, the last one. The hooks exerts a downward force of 1.2 Newton on the platform. The toaster heats the slice of bread and then releases the hook. The springs return to their unstretched length and the bread is launched upward. The mass of the platform is negligible. Determine the speed of the bread at the instant the spring return to their unstretched length. So he asked about the speed. And the speed, you can find it from the conservation law of energy, from the part of the kinetic energy. So we have the, firstly, you can find the elastic potential energy, which is equal to half k delta x square, or you can find it to the or use the other formula, half f delta x. You can use each one of the formulas as you like. Okay, I will use the first one. So we have the elastic potential energy. To find the elastic potential energy, we have a downward force 1.2 and we have the weight. We have the weight, which is the weight of the bread is 0.52 and the hook exerts downward force of 1.2. So firstly, before we use this one, I will move it downward. Okay, so you can find the total extension. Total extension delta x, to use it here or here. Delta x equal the force divided by k. So the force, we have two forces, 1.2 plus 0.52, which is the weight. Okay, divided by k. Which k you will use? I will use k total because we use the 4 springs. 24.76. I will use my calculator. 1.2 plus 0.52 divided by 24.76. I got 0.06946 or 69 meter. So we have delta x. Okay, and then I will use this formula. So we have the elastic potential energy, which will be later on converted into kinetic energy to find the velocity. So it will be half k for the whole parts. It will be 24.76 multiplied by delta x, which is 0.069, all to the power of 2. Half 24.76 0.069 all square. So it will be 0.0589 joule. It's the kinetic, it's the elastic energy. And then the toaster heats the sliced bread and then released the hook. The springs return to their unstretched length. So we have the unstretched length, mean that they will return back to their original length. Before you add the bread. Okay? To understand this part, I should draw it to you. Okay? We have the spring. I will draw 2 springs only. Okay? Like this one. And we have the platform. Okay? So at this point, the 2 springs are fully stretched. They stretched at the maximum height, the maximum extension, till the hook stops them. So we have here the hook. So the total energy stored in the system when they are fully extended is the elastic potential energy. Only it's the maximum value. While the kinetic and the gravitational potential energy will be equal to 0. Both of them will be equal to 0 because it's fixed on the hook, at the hook, okay? And then the kinetic energy, there is no kinetic energy for it. And the gravitational potential energy will be 0 because the springs are fully stretched, so there is no difference, or there is no gravitational potential energy. When it returns back, he asked about what? Determine the speed of the bread at the instant the spring returns to their unstretched length. means that the hook is released. He told you that. Then releases the hook. Okay? So the second position, we release the hook. I will repeat the shape. And for this one, we have the springs fully stretched. I will remove this one. Fully unstretched. They return to their original shape or original length. So we have the elastic energy will be equal to zero, and then the kinetic energy plus the gravitational potential energy will be equal to maximum. Their sum will be equal to the elastic potential at this position. And we have the conservation law of energy. The energy is neither created nor destroyed, just a transfer from one form at this position, which is fully stretched or fully extended, and when it returns back to their original shape or original length, all of the elastic potential energy will be converted into kinetic and gravitational, because the object or the platform will be moved upwards. Okay, so we have the sum of kinetic energy and the gravitational potential energy will be equal to the elastic potential energy. Okay, so we have the gravitational plus the kinetic will be equal to the elastic when fully stretched. Hope you got this one. Okay, so the gravitational potential energy equal to mgh, or the weight multiplied by the height, or the difference in motion, which is here the height will be the extension, the difference, the kinetic energy half mv square. Okay, and then equal to the elastic potential energy, E elastic. So we have the, I can substitute here by delta x, mgh. Okay, so the weight will be, I think it's 0.52. Here is the weight of the bread. Okay, Bismillah. 0.52 multiplied by the extension. Here is the extension, 0.069 when you apply the force and when you apply the weight, plus I will calculate this one, half the mass, the value of the mass, we need this one, which is 0.52 divided by 9.81 multiplied by v square, equal the elastic 0.0589. This part, if someone asks, this one, m is the weight divided by the gravitational field strength. I will calculate each part. This one will be 0.52 multiplied by 0.069. I got 0.03588 plus half 0.52 over 9.81 will be 0.026 v squared equal 0.0589. I will rearrange my equation. Sorry for this disturbance. Okay, I will move this one to the other side by subtraction. Minus 0.03588. It will be, we have this one, let's double check this one, 0.52 divided by 9.81 divided by 2, 0.0256. Okay, 0.0589 minus 0.03588. Sorry for being late. I write this part on the calculator wrong. Okay, so it's 0.026 v square equal 0.02302. And then I will write it here. V square equal 0.02302 divided by 0.026. And then make the square root. I got the velocity 0.94. speed equals 0.9 after making square root meter per second. Alhamdulillah. We finish this paper and we finish this question because the energy transferred from the elastic potential energy to the total other total work done in the form of the gravitational when it moves upward, and when it moves upward, and the kinetic energy when it reaches the unstretched length. So we finish this paper. الحمد لله. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.